Hello, I'm John Nightingale, a director at JCT and the Symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
So hello everybody, it's great to be here, and thanks to John and everybody at JCT for organising this. It'd be so much nicer if we were there face to face and actually in the bar later, but you know, we are where we are, so it's just great to be here and be talking to you today. So to introduce myself, my name's Peter Cattell. I'm one of the solution managers from Clearview Intelligence. If you haven't heard of Clearview Intelligence, we've been around for about 40 years. We've got about 40 years research and development experience in traffic safety systems, in delineation, and in traffic measurement systems. So we've got a lot of experience in a number of fields. The example you can see on the screen here at the moment is actually a delineation scheme. This is in Guernsey. This is our solar studs, and you can see them showing the route ahead for drivers on that piece of road, increasing the safety of the junction. But today we're talking about journey time monitoring. So why would you want to monitor journey times? Some statistics from 2018 said that a typical driver is spending 178 hours a year sitting in congested traffic. Just to put it into context, 178 hours is approximately a working month. Now, I know that at the moment the traffic isn't like it was in 2018, but even if it's only half of that, spending a working fortnight sitting in congested traffic is still not a great result. So anything that we can do can actually improve that, has to be something that's useful to do and something well worth considering. So journey time monitoring is used for a number of different areas around network monitoring. So understanding what's going on your road network and looking at where maybe the pinch points are and where you can actually put some targeted action to improve the way that the network is working. Managing roadworks is an area that it's very commonly used. There's an example on the screen here of a VMS at the side of the road. That's being driven by our journey time system, telling drivers the anticipated journey time through the roadworks and letting them make an informed decision about what they're going to do. Understanding when the peak traffic flows are can be really, really helpful. One particular local authority I was talking to was saying that they were about to deploy a whole load of roadworks on a major arterial route through their local authority area. But when they looked at the journey times that our system was telling them, they realised that they'd misjudged when the peak periods were. So they rescheduled those roadworks and actually avoided causing a lot of disruption to the drivers. Before and after analysis is fairly clear. It's if you're going to be doing some intervention on the road network, understanding what the network was doing before you made that intervention, and then understanding whether you've made an improvement afterwards can be a real benefit. And the final area, it's the one I'm going to be spending a little bit time talking about today, is about incident and event monitoring. So incidents when it's unplanned, but events when you actually know what's going to go on and actually being able to plan a response to what you're expecting to happen. So our journey time system is what we call an Insight journey time system, and it's a crowdsourced data platform. Insight underpins most of our software applications around vehicle counting and classification, around car parking, and as I mentioned here, journey time monitoring. So the system is using crowdsourced data to provide that journey time information. But why use crowdsourced data? Well, typically, if you're putting a journey time system in, you have to install a whole load of hardware. Typically that will be either ANPR cameras or it might be Bluetooth sensors. If you're installing those, you need to consider power and communications for them. You need to install some sort of civil engineering, a pole with maybe barriers around it and so on. So putting that equipment in is not a straightforward process and can't be done quickly. Crowdsourced journey time system, however, means that you can set up a journey time system at the click of a mouse, literally. So you can easily add or change or delete routes at the click of a mouse from your desk without any hardware being deployed at the side of the road, and importantly, without having to put anybody at risk deploying that hardware. And the final point is, it's accurate. This is a chart showing two different journey time systems basically on the same route. The blue trace is the data that was collected from a Bluetooth system, and the red line is the crowdsourced data. And I guess the key thing to look at here is, do the peaks and troughs match up? And I think you can see that they do. So you can see that, you know, we detect the peaks at the same point that the Bluetooth system detects the peaks, and we kind of get a very similar basic level during the off-peak periods as well. So you can see that the system is actually providing a very reliable and very accurate response to what's going on the road network. A little bit of terminology first, just to try and explain things a little. We talk about spans and routes. A span is a distance from point A to point B. And you can see this is one just going into from the outskirts of Milton Keynes into the centre of Milton Keynes. So that's a span, and that's typically what you would monitor. Now, a span can be any route, any distance that you want. But if you want to monitor a large distance, then we typically would combine one or more spans into what we call a route. And you can see here, this is a route that's going from Bedford into Milton Keynes. Now, that could be a single span. But the problem is then, if you had a problem on that route, you wouldn't necessarily know where that problem was. By breaking it down into smaller spans, you get a view of what's going on, and actually you get that kind of that breakdown on the data, and you can understand where the issues are on the network. Looking at some of the output from the system, this is a typical kind of graph that the system produces, and there's a few lines there, and I'll try and explain them. The yellow line is the average journey time. So assuming there was no traffic on this piece of road, that would be the journey time that you would expect. The wiggly kind of pale bluey green line is actually the measured journey time. So that's the actual journey time of the traffic traveling along the road. The interesting line is the purple line. That's what we call our adaptive journey time. So this is our system using machine learning algorithms to guess what the journey time is likely to be. So it learns over a period of time what normal looks like, and then will predict what normal will be like for that particular piece of road at that particular time of day. The benefit with that is it means the red line, we can set alerts based on that adaptive journey time. So we will only alert an operator if it goes above what we would normally expect the traffic to be at that time of day. So it's a really useful feature, this adaptive journey time, that the system self-learns what normal looks like and actually only informs you if there's an issue. Our system also has comprehensive reporting capabilities. You'll see here a chart, but you can also see the heat map below. So you can see the red bits where the speed of the traffic has gone below a certain level. So it immediately draws your attention to that particular area of the chart. So you can see and start to understand very easily and very graphically what's going on your road network. So that's enough about the basis of the product. Let me talk about how Bristol used this. This was a particular challenge that they had around the Aston Gate Stadium. You can see down there in the southwest corner of Bristol is the Aston Gate Stadium. And stadium is a big place. You can see it's a several thousand people go in there, and it hosts lots of very large attendance concerts, the typical kind of pop concerts and so on that you see all over the country. When those concerts finish, it obviously generates a large spike in traffic as the concert goers are leaving. Bristol had a particular quandary because they had a number of concerts, 4 concerts in very quick succession at the same venue. So they decided that they needed to try to do something to dissipate that traffic as quickly as possible. So they were going to adjust the scoot timings on their systems to try and cope with that increased flow of traffic at the particular time that these particular events were finishing. To do that, they needed to understand what was going on their road network, first of all. Obviously, you can only do something if you know what's going on. So Bristol needed to monitor numerous routes around that particular stadium so they could understand what it was they were going to do. Now, as it happens, Bristol have quite a comprehensive network of ANPR cameras that already covered some of these routes. So they were already fairly sorted, but they needed to monitor a few extra routes to get the complete picture. Now you can imagine if they decided that they needed to put some ANPR cameras in or Bluetooth systems in, that would take a lot of planning, and you'd have to procure the equipment and you'd have to install the equipment and blah, 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 blah. So they came to us and said, can we use the Insight Journey Time application to do this? And we said, absolutely. We set them an account up, and literally within a few minutes, they'd set up the additional spans that they needed around the stadium so they could view what was going on with the traffic around the events. So when the events happened, they could see there was a clear benefit of adjusting the scoot timings. But one thing that they noticed during the first event that was, as they took these adjustments away, so they reverted back to their original schedule, the journey time started to increase again. So it was clear that looking at the data that they were getting from the journey time systems, that although the scoot modification was working during certain periods, when it was turned off, the traffic volume, because of the traffic volumes, the journey time was still increasing. So they decided to make an intervention. So the Bristol operations team decided that on the second and subsequent events, that they would extend the period that that adjustment was in place for. So based on the evidence they were getting from the journey time system, they decided to extend the period that the scoot modifications were in place. And the good news is there was clear evidence afterwards that those extended periods actually made a big impact on the people leaving. So the concert goers got home earlier. The traffic congestion around the stadium was obviously reduced. The stadium got a fairly positive response from it as well, I guess. And overall, it was a really positive success. And it was only from knowing what was going on the road network that they knew what they could do. It was only by understanding the traffic flows that they knew that they could actually extend those periods and actually have a positive impact. So that sorted out that problem. But the interesting thing is, if you'd have installed a whole load of ANPR cameras around the stadium, that would be it, and they'd be staying there, and they'd stay around the stadium, and you couldn't do anything else with them. But because our system is so flexible, it meant that Bristol could now redeploy those spans those new spans that they'd created around the stadium, and they can put them wherever they want. So they could now pick those spans up effectively and move them to other events that were happening in the area, particularly around the Glastonbury weekend and events that were happening at the Filton Airfield. So the flexibility of the system meant that they could reuse those spans and actually make a great use of them elsewhere where they couldn't have done previously. Just as a quote, this is from Aaron, one of the guys from the Traffic Control Centre, and you can see there that he stresses about the flexible nature of the system and how easy it is to set up, and also the way that the data that was produced directly influenced their scheduling of those scoot periods and enabled these quicker journey times home for the concert goers. So really a positive outcome from a fairly simple solution. And finally, looking at just as a summary, really, I've talked to you about the monitoring journey times and why you would do that, and the benefits around using a crowdsourced journey time system. The fact that there's no hardware to deploy, there's no civil engineering required, there's no power, there's no comms and so on, means the system can be a lot more responsive, a lot more flexible, and a lot easier to deploy. The data from the system can be fed to VMS, and whether that's fixed VMS, strategic VMS is already on the road network, or whether it's temporary VMS that have been put in for a special event or whatever, we can feed the data to those signs. It has comprehensive reporting, so you can see that the data that you've collected, and that's really what enabled Bristol to understand what was happening, was that they could get the data out of the system, they could understand what was happening and make those decisions about extending the scoot modification periods. And finally, the intelligent alerts, being able to leave the system to intelligently know what's going on and to alert you when you need to know about it is a real benefit to anybody that's a network operator. So hopefully that was of some interest to you. You've got my details on the screen there. If I can be of any help to anybody at any times, just give me a shout. And I'll pass you back to John. Thank you for your time.